Hello YouTube and welcome to the Math Tricks video. In this video, I'm going to talk about quadratic equations and factorizing techniques. To do so, we will go through three main formulas which will enable us to solve all kinds of quadratic equations and factorize a mathematical expression as much as possible. To begin with, a quadratic equation has a standard form like this: ax squared plus bx plus c equals to 0. So, in fact, the quadratic equations is a polynomial with degree 2. And it's really vital to keep in mind that any polynomial with degree n has n roots. So, a quadratic equation, which is a polynomial with degree 2, has to have 2 roots. Having said that, we will go through the most important formula from these three, which is difference of squares. This formula tells us p squared minus q squared equals to p plus q times p minus q. To clarify the idea, we go through example 1 together. We would like to find the roots or zeros of function fx equals to x squared minus 4. So first, let's see how the graph of this function looks like. If we draw the graph of this function, we will see that this function crosses the x-axis in 2 points, namely plus 2 and minus 2. Further, we can see the vertex of this function, which has coordinate of 0 and minus 4. So let's see and find the roots of this function analytically. So alternative 1, which is our main tool to solve all types of quadratic equations, is rewriting this expression in an equivalent form, which is p squared minus q squared. So let's do this together. So we write x squared as it is, and we write minus 4 in this form, 2 squared, and equal to 0. So this expression is equivalent to this expression. So we can write x minus plus 2, which is equivalent to this, times x minus 2, which is equivalent to this expression. And we would like this to be 0, because we would like to find the zeros of this function. To have this whole expression equal to 0, we have to have either this expression in the first pair of parentheses equal to 0, which is x plus 2 equal to 0, and then if we subtract both hand sides of this equation with 2, we get x1 equals to minus 2. And I put index 1 here because remember, the quadratic equation has to have 2 roots. So this is one of the roots. On the other hand, we said to have this expression equal to 0, either the first one should be 0 or the second one. So we wrote down the first one, and now this is the time to write down the second one. So x minus 2 equals to 0. And if we add plus 2 to both hand sides, we get the second root, which is plus 2. So let's go through alternative 2. In this kind of expression, we can say, okay, we don't need to go through this, and we can do it much more simpler. Meaning that if we add plus 4 to both hand sides of this equation, we get x squared equals to 4, and if we take the square roots of both hand sides, we get this one. So square root of x squared equals to plus minus square root of 4, and we should have plus minus because the square root of x squared is x and square root of 4 is 2. but we have two x's, x1 and 2, plus minus 2. So if we put x equal to 2, we get x4 minus 4 equals 0. At the same time, if we put minus 2 squared also is 4. So 4 minus 4 is 0. Alternative 3, which is kind of boring, is using this formula, and this formula use this coefficient in the standard form. So here we don't have a standard form. We will try to write this equation in its equivalent standard form. We say, okay, a is equal to 1, and 1x squared, of course, is x squared, so 1 times x squared plus, we don't have any term times x, so b is equal to 0 times x, so which the whole expression is 0, and then plus minus 4, so c is minus 4, and we would like to find the roots of these equations. Then we will put it equals to 0, and then if we substitute this value in this equation, so b is 0, so minus 0 plus minus a square root of 0 squared minus 4 times a, which is 1, times c, which is minus 4, divided by 2a, which is 2 times 1, and then we will get minus 4 times minus 4 is plus 16, and then divided by 2, and here we had plus minus, so we put them here, and then this is 4, square root of 16 is 4, so plus minus 4 divided by 2, which is plus minus 2. So this result is the same as this and the same as this. So let's go further and present a challenge. Okay, so we would like to find the roots of function fx equals to x squared minus 1 divided by 9. So you can pause the video and try to solve this and find the zeros of these functions, or you can directly, of course, watch the rest of the video. So if we draw the graph, we'll have a happy or a smiley graph which crosses the x-axis in 1/3 and minus 1/3, and we have vertex here. So again, the vertex is has coordinates 0 and minus 1 9ths. I will explain why this is the fact in a bit. So again, alternative 1, we have x squared minus 1/3 to the power 2 equals to 0, and we wrote this expression in an equivalent form of this. So we know that this one has to be equal to this one. So we rewrite it. X plus 1/3 times x minus 1/3 equals to 0. So again, either the first expression in this pair of parentheses should be 0, or this expression in the second pair of parentheses should be 0. So we get x plus 1/3 has to be 0, which gives 1 roots, which is equal to 1 minus 1/3, or this expression in the second pair of parentheses should be 0, which means x minus 1/3 should be 0. If we add 1/3 to both hand sides, we get the second root, which is equal to 1/3. And again, the second alternative, we can add 1 divided by 9 to both hand sides, and then if we take a square root of both hand sides, we get square root of x squared equals to plus minus square root of 1 divided by 9, which gives us 2 roots, and they are plus minus 1/3. So to try, can you try and find the alternative 3 for the above solution? using the formula we went through. Second thing to try, I would like you to challenge you to find the roots of following function: fx equals to x squared minus 25. You can of course using all three alternatives. Thank you for watching. If you liked the video, please don't forget to subscribe, and I will go through the second formula in the next video. Thanks.